All right, here are solutions for perfect problem 6 for Math 112. In this problem, you're given this huge mess of a trig expression and asked to simplify it. So generally speaking, when you run into problems like this, one strategy that will work is to change any of your trig functions, so tangents, cosecants, secants, that kind of stuff, rewrite them all so that they're in terms of just sines and cosines. It's a nice property that trig functions have that allow you to do that. And I'm going to do that. I'm going to do it eventually though, because I think if I do that all immediately with this huge mess, it's going to blow up and get even worse and worse and worse. So what I'm going to try to do is try to simplify a little bit. And when I have something this big, I like to kind of take it in just little chunks. So maybe I'll first take this little chunk right here and try my best to simplify that. So the thing that jumps out to me is in the denominator here, I have a cosecant in each of these terms. So I can rewrite this as cosine of x divided by cosecant of x times 1 minus cosine of x. And if you didn't like cosecant of x down here on the bottom, you could recognize that cosecant of x is the same as 1 over sine of x. So I could write this as cosine of x times sine of x divided by 1 minus cosine of x. And that's not to say this is any simpler than this, but I think this will end up being in a form I can deal with. So really my goal here is to get a denominator that I can match up with this denominator, kind of find a common denominator so I can sort of mash things together. So what I'm now going to do is pick on this term here, and my goal would be to end up with the denominator exactly 1 minus cosine of x would be ideal. I'm just not sure if I can do that, but let's see what happens. So in the numerator I have sine of x times cosine of x. Coincidentally, the same thing I got over there. And then the denominator I have secant of x minus 1, but secant of x is the same as 1 over cosine of x. So really I have this. And so what I'm going to do is get a common denominator down here in the denominator. I'm going to say this is 1 over cosine of x minus cosine of x over cosine of x. And that will allow me to rewrite this as, maybe I'll make it a fraction over a fraction for the time being. So I got the cosine of x times the sine of x divided by 1. And that whole thing is divided by 1 minus cosine of x divided by cosine of x. So I took these guys here and have a common denominator, so I subtracted the numerators. That got me here. But the nice thing about this is when you're dividing fractions, it's the same as multiplying by the reciprocal. In other words, you can take this denominator and flip it upside down, and then I would have a sine of x up in the numerator, and I'd have this cosine of x and this cosine of x, in other words, cosine squared x. And down in the denominator, I got 1 minus cosine of x. Oh, how convenient. Now I got a 1 minus cosine of x here in the denominator and a 1 minus cosine of x here in the denominator. I bet that'll be useful later on. It will. Now let's tackle this thing. Might look like a little too much to take all together, but it'll turn out it's not as bad as it seems. There's a lot of Pythagorean identity going on in here. So the Pythagorean identity tells you that sine squared plus cosine squared of any angle, x for example, is just equal to 1. So right here I got a sine squared plus cosine squared, so that's just equal to 1. Right here I got a sine squared plus cosine squared, so that's just equal to 1. And up here I have 2 minus 2 sine squared x. I'm going to rewrite that as 2 times 1 minus sine squared x. And maybe the logic for doing so will become apparent once I take the next step. So I'm doing a few things in this step. I'm factoring out a 2 from these terms. That's here. I'm changing this sine squared x plus cosine squared x into a 1. And then I'm changing this sine squared x plus cosine squared x into a 1. So what I have is, well, I got 1 minus sine squared x, but 1 minus sine squared x is equal to cosine squared x. If you don't believe me, you can come up with that by starting with your Pythagorean identity and subtract sine squared x from both sides of the equation. What you've just shown is that 1 minus sine squared x is equal to cosine squared x. So right here where I've written 1 minus sine squared x, I'm going to write cosine squared x. So I have 2 of those cosine squared x's plus cosine squared x times tangent of x. And then down in the denominator, I have this one plus this one, so I guess I have 2 plus tangent squared x. And what you might notice is that you have a cosine squared here and a cosine squared here. So you could factor that out. You could factor out a cosine squared x. And what that would leave you with in the numerator is 2 plus tangent squared x. Hey, wait a minute, that sounds familiar. That's exactly what I have in the denominator, 2 plus tangent squared x. I can cancel out this 2 plus tangent squared x with this 2 plus tangent squared x and call this entire thing in green cosine squared x. That'll be really useful if this whole thing is cosine squared x. What I'm now going to do in, I don't know, some color, green I guess, is take these guys and put them together. So I'm going to take this, and I'm going to take this. And what I'm going to say is that I have tangent of x, so don't forget about that guy, times, and then in blue, I got cosine of x times sine of x over 1 minus cosine of x. And then in red, I have this term, which turned into this guy. So I'm subtracting sine of x times cosine squared x divided by 1 minus cosine of x. Okay, I don't remember exactly where I left off, but it looks like I have down here created a common denominator, which is always advantageous. Because now what I can do is I can subtract these two rational expressions, fractions, you can think about them like that because they have the same denominator. So what I can say is that I have the tangent of x times, and then instead of this divided by this minus this divided by this, I could say this minus this divided by this. In other words, the cosine of x times the sine of x minus the sine of x times cosine squared x divided by 1 minus cosine of x. And you might be wondering why that helps any. Well, I think I'll be able to cancel out this 1 minus cosine of x. If you stare up at the numerator here, both terms have sine times cosine in them. This is just sine times cosine, and this is almost just sine times cosine. It's just got an extra cosine hanging out. What I'm saying is that if I factor out sine of x times cosine of x from the numerator, what I would have left up in the numerator would be 1 minus cosine of x. And that's awesome because I have a 1 minus cosine of x in the denominator, and now I can cancel those guys out. So what I've done is this thing in blue went here and this thing in red went here, and then I kind of joined it all back together in green. But the thing in green is going to simplify pretty nicely. The thing in green is just going to be equal to the tangent of x times the sine of x times the cosine of x. And you might be satisfied at this point, want to kind of leave good enough alone. But I'm going to take it a step further. As I mentioned earlier, you can always write trig functions or rewrite them in terms of just sine and cosine. Tangent, for example, is sine of x over cosine of x. And so what I now have is a cosine of x up here in the numerator, essentially, and a cosine of x down here in the denominator. I can cancel those out and get just sine of x times sine of x, aka sine squared x. So if you follow all this, maybe it's time to switch colors again. I have a sine squared x here and a cosine squared x here. And what was going on is those two things were being added together. So what I have is sine squared x plus cosine squared x squared, taking all these pieces from the original thing. But sine squared plus cosine squared is just equal to 1. And 1 squared is just equal to 1. So this entire mess that I started out with simplifies all the way down to 1, which is kind of nice, I guess. I don't know if this is the best way to show you your work. I certainly know that this is not the only way you can solve this problem. But this is one way, kind of taking it in chunks like this and then putting it all back together. But I'll leave it up to you how you want to solve this thing. Here's one version of the solutions. I'll call this good.